Welcome to Third Angle, where we're grasping custom-designed prosthetics. I'm your host, Paul Hames, from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Open Bionics is a truly inspirational company developing affordable, custom-made prosthetics. Their flagship product is the Hero Arm, a clinically approved lightweight prosthetic arm. They also make the Gauntlet, a partial hand prosthesis, and the Hero Flex, an activity arm. The company's mission is to make prosthetics more accessible and beautiful, with designs including Marvel and Disney brands. The Hero Arm has changed the lives of around 1,000 children and adults, and is available to both private and National Health Service users in the UK, and through prosthetic clinics across the UK, USA, and Europe. Our producer, Clarissa Maycock, visited the Open Bionics headquarters in Bristol, UK, and spoke to their Chief Technology Officer, Damian Axford. Damian takes us on a tour around their lab and offices and tells us about the company's commitment to turn disabilities into superpowers.
Welcome to Open Bionics. My name is Damian Axford. I'm the Chief Technology Officer here, and we're at the Bristol headquarters. And we'll start the tour just round to our right in the clinic. This is one of our clinics around the world. So this is the UK base of operations. So this is typically where patients will come in either to be assessed and then hopefully cast and ultimately fit with a prosthetic arm. And then as you can see around the room, we've got lots of demo products and various bits and pieces. So as an example of the products that we make, this is the Hero Arm. This is our flagship product. So this is a myoelectric prosthetic arm, which basically means it uses EMG sensors or electromyography sensors. Those pick up the nerve signals that go into the muscles on your forearm. So the way the arm works is if you've had an amputation and you've still got some of your forearm, basically we place sensors on the remaining muscles, and that's what's used to activate the hand. So as those sensors activate, you can then change the position of the fingers or change the grip that it's in. So in this case, so that's a grip change going through. So this allows the hand to move between, say, a pinch grip for picking up small objects to something more like a fist grip for picking up, say, a glass of water. So this is affectionately known as the cover wall, i.e. a wall of hand covers. So many prosthetics, particularly if you go back to, say, 20 years ago, they were predominantly made to be like fake limbs. So they would come in a sort of mock skin colour. The idea was you were hiding your prosthesis from the world and trying to pretend like you had a regular limb. Open Bionics, part of our differentiation is to shy away from that and to celebrate the fact that it's a prosthetic arm. So what we try to do is give people many ways to be individual and express themselves. And the primary way we do that is with custom covers. So on the wall, you'll see some of our standard covers. And then we've got partnerships with Disney and with Marvel. So we have a whole line of covers that are designed around their brands. What we often end up doing now is when they launch a new major movie is we'll do some sort of partnership arrangement and create a cover design for that particular film or character. So most recently was Moana 2 at the end of last year. We made a set of Moana 2 covers for a young girl in the States as a one-off special. So she got a Disney special day with custom covers, custom arm, the full works. So when people are coming in for an arm, you've got the arm itself, and then you've got the, pick from the cover wall, what sort of texture, colour, finish you would like. So the company was formed a smidge over 10 years ago. So it grew out of the robotics kind of scene in the universities of Bristol. So our founders, Joel Gibbard and Samantha Payne, They started the business here, coming together to challenge the way prosthetics are produced. So yeah, the company's mission is very much to make prosthetics more accessible and to celebrate kind of individual expression and creativity. So we do not want to make bland products that hide away. We are unashamedly robotic and prosthetic. Instead of perhaps a amputation or a prosthetic limb being something they would hide or be ashamed of, or for children maybe something they're ridiculed for, hopefully our products turn that into something to be celebrated and shown off. So we often hear from our users that it helps boost their confidence. We're here to turn disabilities into superpowers. And we do that right from, well, age 8 is where we begin our product line at the moment. Younger than that, it's because children's limbs are changing shape so rapidly, it's kind of infeasible to fit an expensive arm and have to then remake the socket constantly. After about age 8, it's not so bad. It still requires constant refits, but it's a good compromise. In the Hero Arm product as it stands today, there are basically a set of miniature linear actuators in the hand. So you've got small motors that drive a threaded rod, and that moves a nut that slides along that threaded rod backwards and forwards. The nut in turn pulls on a tendon, which is not dissimilar from fishing line, something like a very high tensile strength thread, and that runs through channels into the fingers and ultimately causes them to close. Not dissimilar from the way our normal hands work. They have tendons running through them and muscles in your forearm pull on those to move your fingers. It's very analogous, but yeah, thread and linear actuators. So this is our production space, and you'll have to forgive production noises in the background. So the rattling noise going on in this room, this is our wet room. So this is where we do the spray finishing on covers particularly. So any of those like Disney or Marvel type covers, they're hand finished. So they will get a base coat of colour, typically a white primer, and then all of the detail paintwork is done like any other model shop. It's masked up, it's kind of hand painted and finished, and then lacquered in here. So there's a whole kind of ventilation controlled spray booth area. This is also where we cast all of the silicone and urethane fingertips and grip surfaces. So on the hands, there are squishy pads on the fingers and the palm. All of that's cast in here. So there's a whole moulding process, vacuum degassing and other bits that go on. One of the biggest challenges is creating very lightweight products that are comfortable to wear all day. Traditional processes of constructing a limb, such as a silicone liner and a carbon fibre socket, they are relatively heavy compared to what's possible, and the silicone liners, they're not breathable, so you end up with a very hot, sweaty product. So wearing something like that for long periods of time is not particularly pleasant, and as such, the rejection rate on prosthetics, i.e. you get an arm, potentially after years of trying to lobby for funding and all the rest of it, you finally get this wonderful myoelectric arm, only to discover it's fairly horrible to wear for more than a couple of hours. And ultimately the thing ends up in a cupboard as a sort of prop around the clothes. So right when we began, one of the novel things we thought we could bring to the market and have done is to make the arm breathable and considerably lighter than the traditional process. And the way we've achieved that is with 3D printing. So when we began, that was with, I would say, hobbyist grade printing processes. We moved on that to more industrial processes. But for many years, in fact, I would say until probably the last 2 years, that was kind of laughed at by the rest of the industry. So the bigger mainstream players were very much in the way we do it is the way it should be done. This 3D printing thing is a gimmick and not to be taken seriously. Whereas I think if you look at the trade shows, the industry trade shows as of last year, 3D printing is everywhere now. Everyone's finally accepted. It's a very good way to achieve the technical goals. We've been doing it for many, many years now and have refined that process. So our products are still the lightest on the market. And if you look at user feedback scores, they generally win the comfort kind of prize across the board.
Hi, I'm Evie. I work in the marketing department at Open Bionics. I have the wonderful job of speaking and meeting some of the kind of day-to-day patients that wear the hero arm. And it really ranges. It could be a child in New York who really wanted the hero arm so that he could do two-handed activities like ride a scooter or hold a bottle and then blow bubbles with his other hand. It could be someone who has gone through a traumatic life-changing experience of losing an arm due to kind of a farming accident, and then wants to kind of regain that independence and be able to kind of work in the same kind of occupation. So yeah, the kind of the case studies and the people that we work with really vary from, you know, the ages of 5 to 82, and from different kind of geographic locations as well. We work quite a lot in the US. We have 6 clinics in the US at the moment. So we get a really kind of diverse range of stories coming through as well. We always hope that kind of our technology is tested to its absolute limit, and we love hearing from the community. So a lot of the features in the hero arm actually were feedback that we've had from the limb difference community, where they've said, oh, it'd be cool if this did this. Yeah, we love hearing all of that from the community, and loving seeing ways how they are able to kind of go after their own goals. So we have Tori, who is in Colorado. One of her biggest kind of ambitions now is to train for the triathlon for the Paralympics 2028. And she's just been fitted with her 2 hero flexes so she can ride a bike. She's a very active runner right before her kind of amputations. And now she's training to swim as well. But for her, kind of the Paralympics 2028 is the absolute goal, and she's looking at kind of assistive devices to help her get there. So yeah, we've got quite a lot of people who are really determined in their fields and determined in their hobbies to achieve their absolute best. And we love supporting, and we love hearing kind of how they use our technology to get there.
I think the journey for everyone here has all been quite different. Like, there's not a standard type of person that works here. We've all come from different backgrounds. For my part, I studied cybernetics many years ago, then went off for a long career in corporate FMCG, making snack food and other products. I'd always wanted to move out of that, though, into something that was more kind of socially focused, more community focused. And just looking for the right opportunity, and then the chance to join Open Bionics came up, and it's a company I'd been watching, and in fact a friend of mine worked here for several years, and when the right role opened up I leapt at the chance, and it's fantastic. No regrets. It's one of the best places I've ever worked. So I think from a future point of view, technologies like 3D printing are now becoming almost commoditized. You know, whereas we were extremely novel to use the technology and advance with it, now that technology is everywhere. The challenge is, how do you design and manufacture products in a mass production process but still customize every single one efficiently? That's very hard to do, and that's all down to the design process and the business model you put around it. So I think the future of prosthetics is much more about the design process and the business model than it is about the final thing. The other advancement, I think, will come in the sensing technology. So all prosthetics pretty much today use EMG sensors. There are a few manufacturers that make those. We're one of them. We do make our own sensors, but there's only so far you can push the performance of EMGs. I think there will be a shift in sensing paradigm over the next 5 to 10 years to try and make it easier to adopt and use and more immune to interference. I think the last advance will be in using AI techniques. So the similar sort of deep learning models that run ChatGPT can be applied to interpreting nerve activation and controlling prosthetics. That's been proven in research. The problem is trying to miniaturize it and run it at the low power levels that we can afford in a prosthetic. So I think advances in battery tech and computing will help that tick into the mainstream. So I think aside from the clever tech, the difference for your average user getting a replacement limb should be, one, you can receive that limb far faster. Today we can deliver a limb in about 4 weeks. We hope to halve that or better. 2, today we have to shy away from too many volume changes to the limb. Like fitting younger children is cost prohibitive. I think we'll be able to cross that barrier to the point where it's not cost prohibitive. You can just have a limb at any age and service it when you need. And when you do finally get that limb, today it takes quite a lot of practice to learn to use. I hope we can get past the practice stage to an almost immediately usable, intuitive limb.
That was Damian Axford sharing Open Bionics' commitment to making prosthetics more accessible. Now it's time to meet our expert, John Hirschtick from PTC. John, Open Bionics have been using PTC's cloud-native product development platform Onshape for nearly 8 years. It has successfully reduced design time as well as accelerating communication between hardware, electrical, and firmware engineers. Are you able to give us an insight into how Onshape has enabled these major benefits?
I'm going to answer your question by breaking it down into a few different areas. 1, Onshape's CAD configuration capabilities, which are way beyond what you could do with older installed products, because our cloud-native system provides CAD configuration capabilities that enable streamlined management of multiple design options within a model, removes the need for separate files for each variation. This simplifies the CAD process, reduces errors, and allows quick adjustments to parts or assemblies, and boosts efficiency and flexibility in product development. By using this, Open Bionics have reduced their design time by more than 75% on their prosthetic wrists and hands, which are offered in multiple sizes and in right-handed and left-handed versions. So that's the first area, Onshape's powerful CAD configuration. Second area, Onshape's branching and merging tools. That allows you to build variations and experiment with new ideas in your documents. They've empowered the engineering team to rapidly explore more alternative design ideas, 3D print prototypes, and get faster feedback from bionic arm users. Third area, Onshape's real-time simultaneous editing accelerates communication between hardware, electrical, and firmware engineers. And lastly, Onshape is cloud native, and we offer not only CAD, but also PDM without any need to purchase any servers or special workstations at all. Open Bionics is an amazing company and one that is pushing the limitations of prosthetics to another level.
Thanks to John and also to Damian and Evie for taking us behind the scenes of Open Bionics. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and X for future episodes. Companies that make the products the world relies on rely on PTC. This is an 1860 production for PTC. Executive producer is Jackie Cook. Sound design, editing, and location recording by Clarissa Maycock, and music by Rowan Bishop.